Question number 6. A particle is projected from a point O on horizontal ground. The velocity of projection has magnitude v meters per second and direction upwards at 35 degrees to the horizontal. The particle passes through the point M at time t seconds after the instant of projection. The point M is 2 meters above the ground and at a horizontal distance of 25 meters from O. Find the values of v and t. Second part, find the speed of the particle as it passes through M and determine whether it is moving upwards or downwards. Now here is the situation when illustrated on a simple diagram. The object is projected 35 degrees, it passes the point M, which is 2 meters above the horizontal ground here and 25 meters away from O. I would use the Cartesian equation of the trajectory. So y, which is 2 meters, so I'm going to say then 2 is equal to x, which is 25 meters, times the tan of theta, tan of 35 degrees, okay, minus gx, and g turns out to be 10, x squared, which is 25 to the square, divided by 2 u squared, which is v, so v squared, and then sec square theta is basically 1 over cos square 35. So we're going to do this on our calculator. Therefore I've got 2 is equal to 25 multiplied by tan of 35 is 17.5051 and so on. This 2 goes in here, we've got 5, and I've got 5 multiplied by 25 to the square, which turns out to be 3125. So 3125 divided by cos 35 to the square, so I'm going to say cos 35 times the cos of 35, so that's cos of 35 to the square, and then you got v square, so which is 0.671 here, this one, over, then v square. From here we want to find v, so this can go on the other side, and I've got then 17.5051 and so on. Take away 2 is equal to, and let's divide this 3125 divided by this is this much. So I got then here 657.15814 over v square. This is going to be equal to 15.5051 and it's equal to 4657.15814 over v square. So v square is equal to all of that divided by this. Turns out to be this much. 300.3629847. So v is the square root of all of that. So let's take the square root of this, 17.3309. So on. So I can say v is approximately 17.3, and that's the answer to the first part. Now to find the time it takes for the object to travel from here to here, I'm going to first look at let's say the horizontal velocity. So I want to find Vx, the horizontal velocity, which turns out to be, this is v and this is 35 degrees. So Vx is the horizontal velocity, which is then v cos of 35 degrees. Okay, so now what we're going to use is that this distance here, which is 25 meters, is the distance traveled by the object. So I've got then the distance is equal to Vt, the speed multiplied by time. So time is equal to then the distance over the velocity, which is the horizontal velocity, which is then 25 over Vx. So that means the time is going to be t, or the value of t is going to be 25 divided by Vx, which is v cos 35, and v turns out to be 17.33, so 17.33 times cos of 35 degrees. So that gives me t as 25 divided by 17.33 times cos of 35. Answer is 1.76. So 1.76, 107, etc. So I can say T is approximately 1.76. And here we are for the complete first part of the question. Okay, for the second part of the question, we need to find the speed of the particle as it passes through M, and then also need to determine whether it is an upward or downward movement, whether it's moving upward or downward. Now, first of all, I want to find what's happening here. Now, over here, as we can see, there's a horizontal component, and here's our vertical component, and here's this resultant force. All right, so at that point we can find, if we want, the vertical component of the speed and also the horizontal component of the speed, and giving us the resultant, which is Vm. That's the speed we want to find. Is by using Pythagoras theorem, we can take the horizontal component, let's say Vx to the square plus Vy to the square. So basically we're saying Vx turns out to be V, which is 17.33 times cos of 35 degrees, plus Vy, the vertical component of the speed, is going to be equal to, so what we have is then T is 1.6, so therefore we got then 17.33 times the sine of 35. Okay, take away the gravity, force of gravity, because this is the vertical component. There's a force of gt acting downwards, so minus 10 times the time, T is 1.76. That's the y component. All of that to the square, here to the square, and you do the square root of that. So that's the final speed, I mean the speed as it passes through M. So let's put in a calculator, 17, okay, 0.33 times the cos of 35, and you square that. Then you add to, hang on, let me just, 17.33 cos of 35, and then you square it, you should be able to get 201.523. So on, alright? Plus, this one now is 17.33 multiplied by the sine of 35. Take away the 17.6, turns out to be negative. So we're getting negative velocity on the y component. So negative, remember that, negative 0.7659 and so on. Means that this is a downward velocity. So in other words, this is to the square, and you do the square root of all of that. So you square the result. You get this much, you add up with 201.5237, that's total, of 260.198 and so on, square root of all of that. And let's take the square root of this, 16.1305, 65, etc. So the final, I mean the speed as it passes M, I'm going to call it Vm, is 16.1 meters per second to 3 significant figures. Here we are for the second part. Take care.